So, hi everybody, and welcome to today's OWASP Switzerland event. Once again, the event unfortunately has to be held online, but I guess most of us are used to that by now, and we see that we still have a rather big crowd that came to today's event. So with me today is Paddy and Rob, and I myself am Sven. We are leading and organizing the local chapters here in Switzerland for OWASP. And with us today is, of course, already also our speaker, Peter, which will also be introduced later on. So without further ado, just very few statements for how the event is going down and how you can participate for today. And then we will dive right into. So I guess as you're joining us today, you have at least a slight idea of what the Open Web Application Security Project, or short OWASP, is. If not, OWASP.org is the main page where you find a lot of information about any kind of application security topics. And as you might have already noticed, today's event, like all of the OWASP events and also all of our material, is completely free, which means a lot of people are working without any kind of payment. So if you still think it's a worthy cause and you want to support OWASP, there is the possibility to become a member of OWASP, either as an individual or as a company. And of course, we would highly appreciate if you at least consider that. And you can either just scan the QR code or type in owasp.org/membership to get more information about how to get involved with becoming an OWASP member. And beside that, of course, we are always happy to have people joining OWASP projects and support them with code, documentation, whatever is needed. So for today, there is possibility, even if it's an online event, for you to join in, or at least somehow to join in. So you are looking at the current event now on YouTube. So this means you have no possibility to directly interact with us or the speaker in terms of like audio, video. But what we have is a possibility for you to either send in questions that you have directly on YouTube. That should be normally on the right-hand side where you have a chat window. There you have to be logged in to do that with your account at Google. But for people that like to stay anonymous or also don't want to log in and have this recorded, we also offer a small site at owasp-switzerland.ch, and there you will find a possibility to enter your name. This is optional. You can keep it anonymous, and you can add your message or question. All the questions we will cluster and put together. And if it's not something that we think is absolutely urgent to ask right now, or if there are any technical issues, then the questions will be answered at the end of the actual presentation. So stay with us till the end. There will be the Q&A session. So just go to the owasp-switzerland.ca page, put in a name, put in your question, press send, and then you will see right away that your question was posted, and we will see it. And without further ado, this was it from the organizational perspective. And now I like to introduce and welcome Peter Sufliarski from Compass Security, who's our speaker today and who will be talking about the new and or the new famous OWASP Top 10, which was released end of last year in a new version, and will show us all the cool stuff that came in and what changed and how this project looks like. So with that, thanks, Peter, already for being here today, and then I'm handing over to you. Sorry, Peter, you're still muted.
Now it should be better.
Perfect.
Hello. And let me start my presentation. Is everything as expected now?
Yep, perfect. Thank you.
Okay. Thank you for joining this event. I'm going to talk today about OWASP Top 10 2021, which is the latest version. I'm not going to add much about myself. As already Sven mentioned, I am working at Compass Security as a penetration tester. And previously, I was working as a software developer, mostly developing web applications in Java. And yes, well, then let me start my talk. This is going to be the structure of my talk. So at the beginning, I'm going to introduce OWASP Top 10 generally. What is actually OWASP Top 10? I will talk a little bit about methodology, how OWASP Top 10 is created. And then we will talk about new things in OWASP Top 10 2021 and compare it with the previous one. After that, we are going to talk about each of those 10 risks, which are included in OWASP Top 10. And depending on the time, I will show you some demos so you can have a better idea how it looks like when those risks in OWASP Top 10 are abused by attackers. And finally, there will be time for questions. But if you have any questions during the talk, then you can, of course, send them. And I will do my best to answer those questions as soon as possible. Good. So generally, OWASP Top 10 is actually a list of 10 most frequent risks in web applications. It does not tell what's the likelihood of some vulnerability in your application. It's not focusing on vulnerabilities. It's just risks which the OWASP Foundation believes you should consider with the highest priority in your web applications. The first OWASP Top 10 was released in 2007. And since then, we have 7 updates. The 7th update was released in September last year. And there are some interesting changes. Maybe an interesting question would be why it was released in 2021, 4 years after the previous one, because the previous one was released in 2017. So as far as I know, there was a plan to release OWASP Top 10 in 2020. However, because of pandemic, there was not enough data. There was some data available, but mostly from companies who do static source code analysis. And this data wasn't really enough to do a quality analysis on the top 10 risks, because people who do software development, then you probably know you have probably observed that if you are using static source code analysis, it gives you a lot of false positives, and therefore the authors of OWASP Top 10 needed more data, and then they got some data from bug bounty companies, and this data is actually very interesting for our use case for the OWASP Top 10, because bug bounty companies, they have data about real vulnerabilities which could be exploited. Somebody acknowledged them, and eventually somebody got some reward. So these were real vulnerabilities. So now in since September, we have a new OWASP Top 10. Finally, there was a data set of more than 500,000 applications. And yes, using this data set, the OWASP Top 10 was built. This data set is going to be available, or maybe it is already available. So if you like data science or you would like to do your own analysis, you are welcome to do it and maybe present your own results if you believe they could be interesting for the community. However, this data from applications, it wasn't the only source for creating the top 10 list. There was, for example, also a community survey conducted where the creators of OWASP Top 10 asked people in the community about risks which they believe should be included in OWASP Top 10. Why the data set of 500,000 applications is not enough? Because these issues are actually looking into the past. These are something that happened in the past, but maybe they don't tell us so much about what we could expect in the near future to be important for application security. And therefore was also this survey conducted. Also, the OWASP Top 10 is focusing rather on the incidence rate of those risks rather than the frequency. That means if you have, for example, an injection, there might be an application which has a systemic issue and has, let's say, 100 injection type vulnerabilities. And there might be applications which have only a single access or some injection vulnerability. And so it has shown that it's better to show with this OWASP Top 10 what's the chance that your application is going to be vulnerable. It doesn't matter if it is completely full of vulnerabilities or has only a single one. Now I wanted to also show you the results of the community survey, which we will see later that looks differently from the OWASP Top 10. And thanks to this survey, some risks were also included in OWASP Top 10, even if they did not occur so often in applications, but there's a chance that they will be present in many applications in the near future. And since these risks seem to be seem to or for example, as you see the first one, server-side request forgery, it seems to be an issue which could cause like big issues. Now let's jump to the actual OWASP top 10. I created this slide. I hope I will be able to show you some useful comparison between the previous OWASP top 10 2017 and the current one 2021. The interesting thing, actually, the first point is already very interesting. Injection. If you are watching OWASP top 10 for a longer time, you probably know that injection was on the first place probably since there is OWASP top 10, or at least in some form. So there was either cross-site scripting or injection on the first place. Now in the latest OWASP top 10, injection was moved to the third place, which is actually a very good thing that because this is showing that developers and people in security, they really try to avoid the main or the largest risks, which are known in which we know in security. There is the reason why injection fell to the third place is mainly that developers are using frameworks which are secure by default. So if you are developing web applications, you are probably using React or AngularJS or maybe some other JavaScript framework which have very good defaults for processing the user input and displaying it back to the user. And therefore, if you don't do some really non-standard things, which you of course can do with JavaScript, then you might be safe, or you should be safe from injection. If we look at the first place of OWASP top 10 2021, we see that actually broken access control moved from the fifth place to the first place. This is also, in my opinion, very interesting. And the reason is that it is, or according to the creators of OWASP top 10, that if you have some vulnerability in this category of broken access control, these vulnerabilities seem to cause the biggest impact on your data. You can imagine you are if you are storing some sensitive data, you don't want to lose it, and if you introduce, or if there is any kind of access control issue in your application and somebody is able to abuse it, then you lose your data, and that's very bad. And therefore, because of this potential impact, this was moved to the first place. Then the second one in OWASP top 10 2021, cryptographic failures. These are issues which happen when you are using outdated cryptography. You are not protecting your data at rest. Maybe your web server is misconfigured and does not does not encrypt the data properly, and such things. Then, as we already mentioned, the third one is injection. This is still a topic, but seems to be a bit more under control. The fourth one is actually a new one. This wasn't there before, and this is called insecure design. We will talk about it a bit later. Then we have security misconfiguration, which moved on one place from 6 to 5. Vulnerable and outdated components. Then we have identification and authentication failures, which was previously on the second place as broken authentication. After this A8, there is software and data integrity failures. This is also partially a new one, and also insecure deserialization, which had previously its own category, was included into this. We have security logging and monitoring failures on place 9. And on place 10, there's server-side request forgery, which I already mentioned on the previous slide. And this was included thanks to the survey, the community survey. The creators of OWASP Top 10, they acknowledged that this is something that we should keep on eye. And now let's talk about these issues a little bit more. Let's start with broken access control. At the beginning, a little bit of statistics. It was, as I already mentioned, there was roughly 500,000 applications. This type of issue was found in 300,000 times in 3.8% of applications. What is broken access control? Broken access control is typically some violation of the principle of least privilege. That means you should typically design your application to allow only the necessary operations to your users and nothing more. If it is broken, that means some users or maybe external people who don't even have accounts can access some functionality which they shouldn't. Another example of this is bypassing access control checks by modifying the URL. You can imagine this, for example, when you have an API, and this API allows you to retrieve some data about some objects or users, anything. Let's imagine you as a user have access to some set of objects, but maybe if you define some ID in that URL of an object which you are not supposed to access, maybe you will be able to access it because there's no checking on the permission of your account. This is also called IDOR, insecure direct object reference. That means, yes, you can reference the objects directly without checking security. Then another case could be, again, if you have an API, you might be able, using that API, to get some data using GET requests. But maybe you can replace this GET method by post, put, delete, and then you can do you can actually change information or even delete it. Just because the application or the service is not checking whether you are allowed to do it. Then to this category belongs also elevation of privilege. So you can imagine you are some user of an application, but it might be possible that you can do some actions which bring you to the administrative center, or which allow you to do something as if you would be an administrator or any other user which has more permissions than your account. In recent years, it's very popular to use JSON Web Tokens. Again, if those tokens could be manipulated, you are likely to access some functionality which you are not supposed to. Similar thing can happen also if you are using SAML for a single sign-on, for example. You might be able to log into application as if you would be some different users. The last point I already briefly mentioned. You could be, for example, able to browse administrative pages just by typing the URL, and if the application doesn't perform proper checking on your access privileges, then you might be able to access this administrative functionality. How to resolve these issues? You should design your application to deny by default. That means if something is not allowed explicitly, you cannot do it. Also, if you are working with objects or records, you should also enforce ownership on them. So you should be able to know if somebody is trying to access an object within your application or system, you should be able to check, does this user have access to this object or not? Also, it is important to log access control failures. So if there is anything suspicious, you should log it. I mentioned the JOT tokens. It is important to properly validate the signatures in JOT tokens, make those JOT tokens short-lived, and there should be also a revoke mechanism if possible. So if the user, for example, clicks on log out, then this token should be revoked immediately if possible. Also, a good thing is if you have an API, you should implement rate limiting, so nobody can just brute force it and download a large amount of data within a short time. Next one, A2, cryptographic failures. Again, a little bit of statistics at the beginning. Cryptographic failures happen usually if you're using unencrypted protocols, like, for example, HTTP. Sometimes it might happen that you are using a web application or web service, and you forget to block access to HTTP, or you don't do a redirect from HTTP to HTTPS. HTTP is not the only example of such unencrypted protocols. There's also FTP, SMTP. Also, there could be, for example, start TLS, which is encrypted, but at the beginning, when this protocol starts, you are communicating without encryption. These encryption should be implemented not only for external communication, so not only for communication through the internet, but you should also enforce use of encrypted protocols within your internal infrastructure. Then we have another example, weak cryptographic algorithms or hashing algorithms. I had, for example, recent a pen test and of a web application, and I realized the web application is using an outdated or let's say weak encryption algorithm. This still happens, and it's not good if, for example, you are storing user information, including passwords, and you are not protecting those passwords properly. So it might happen that the application only encrypts the passwords, and if it happens using some outdated or weak algorithm, maybe even with a well-known default key, that might be an issue, because then you are not really protecting the data on rest. If somebody gains access to this data, then it is possible to break some of those old encryption algorithms within days, or maybe even quicker, depending on how much information you have. Therefore, you should watch for the latest best practices, what kind of encryption and hashing mechanisms you should use, and use them. Then another example would be the strict transport security header. If you are developing web applications or APIs, you are probably returning this, which is telling to the client this application or API is should be always accessed via HTTPS. If you are not returning this header in your application, then you should probably consider adding it. Next thing, server certificate validation. If you're connecting to some site and it shows you server certificate is invalid, then you are not really trustworthy. If you just leave it for a longer time, your users might get used to it, and if they are used to it, then there's a higher risk that somebody will perform an attack, and people will just not notice, because invalid certificate is something that's normal for them. Last but not least, proper use of random number generators. So if you're using encryption, you should, or if you are working with random numbers, you should probably use cryptographically secure random number generators. For example, in Java, there's secure random instead of random, etc. Many of these issues can be already discovered using static source code analysis. So, for example, if you are using some outdated encryption, then it is possible that your static source code analyzer will raise some warning that this is already outdated and not safe to use. Then we have number 3, injection. Injection means that probably some user supplied data is not validated or sanitized by the application. It is important that if you receive some data, you should, if possible, you should validate it and sanitize. if you need to accept any kind of input, then you should sanitize or escape the data when you are printing it. As I already mentioned at the beginning, if you are using modern JavaScript frameworks, this should not be a big issue for you. This kind of issues can be also discovered if you do some dynamic analysis using scanners. It can be automated quite well. Yes, just few concrete examples: XSS, SQL injection, OS command injection. We will probably see some of these later during the demo time. Insecure design, number 4. That's this category may look too general, because somebody may think, yes, insecure design, that could be anything, but it's actually not. It's important to note that if you design flaws are not the same thing as implementation defects. Also, if you have a secure design, it might still happen that the implementation is insecure. But on the other hand, if you have a insecure design, you cannot save it by doing a secure implementation, because it's fundamentally flawed. And yes, these kind of issues may happen if for example, your business requirements concerning the confidentiality, integrity, availability are not clear. Or another example would be password recovery process. How are you using your password recovery in your application? Can you actually can users recover passwords? How they can do it? Some applications allow recovering passwords using questions and answers, but everybody who used it previously probably knows that these questions are sometimes so easy that there might be many people who can answer those questions. And maybe if you are good with looking up information on social networks, then these questions are not really a security mechanism for you. Next example would be missing protection against bots. So you probably don't want that somebody would download all the data from your application within a short time, or maybe you are maybe you have some application, some shop where maybe you are selling something, so you probably don't want to lose money because somebody just made an order or booked all the things which you have in your shop, but and then you cannot sell to other people, and then a few minutes later or a few hours later the attacker would just cancel the order. That would be bad. Another example: unrestricted file upload. Yes, for example, if you have an application, you probably don't want to accept any kinds of files. You you should define some list of files which should be accepted, and most of the time you don't need to accept executable files. You should be checking for malware, for Office documents with macros, which could be dangerous, etc. Incorrect privilege assignment. If you are working with user roles, then you should really do a proper analysis. What user categories you need? What should the users be able to do? What they shouldn't be able to access by default, etc. And also you should protect your credentials. Next one, security misconfiguration. Again, some examples. For example, missing security hardening. That means you might have a quality product, but you did not use all the security features which it provides to you. Or for example, improperly configured cloud services. That's something that's very happens often now, because everybody is moving into cloud. And for example, from my experience, people don't realize always that if you create resources within cloud, many of these resources are exposed to the internet by default. And then things could happen, like, for example, you have a web application, you place a web application firewall in front of this application, but you forget to lock down this application, which sits in your cloud. And suddenly you have a situation where you have an official URL which brings you to the web application firewall, and after the web application firewall, it jumps to the application. But there might be a second URL directly into the cloud, and you just bypass all the protection because you forgot that by default the resource is open to the internet. That's something that happens very often, or not exactly this case maybe, but similar cases where resources are exposed. Then for default accounts, many applications, if you deploy them or install them, they come with some default administrative accounts, default passwords. It's important to remember that these accounts are there, and they should be removed as soon as possible if you cannot deploy the application without them. Because if there are default accounts, then there's a big chance that those have well-known passwords, and somebody will be able to access those accounts. Again, also next thing, error handling. When something unexpected happens, do you make sure that your application is returning only the necessary information to the user? Maybe it's exposing too much. It might happen, and then an attacker can abuse it. Development frameworks, application servers, they provide a lot of configuration options. You should use them, and you should use secure defaults. For example, in case of development frameworks, one example of security misconfiguration is the XXE, XML external entities, which is now actually included in this category, security misconfiguration. XXE happens exactly when you, most of the time, when you misconfigure your framework. Most of the modern frameworks are secure by default, but you may allow, maybe explicitly, these external entities, and then you might have an issue. Security headers, if you are using web applications, content security policy should be used. Another example: outdated systems, disabled, or maybe you might have even up-to-date system, and but your security features, your state-of-the-art security features are just not in place or disabled. Six vulnerable and outdated components. Yes, we observed this issue last year. Probably many of you know the story about SolarWinds attack, or other, or sorry, not SolarWinds. I was thinking now about the Log4Shell. So yes, it may happen that some of your dependencies which you are using for creating your application has a known issue, and you should know about it. You should keep a list of your dependencies and the versions, and also you should join the mailing lists or yes, many of those frameworks or creators of the frameworks provide also an possibility to send you emails if some security issue is discovered. You should update your outdated components, and you should do it as soon as possible, because those components evolve in time, and if you don't update them as soon as possible, you may get into a situation when the next update would create compatibility issues, and then you have a lot of work to do, and maybe you have no time, resources to do it, and that might be bad. Also, patching should be done, if possible, immediately when patches are available, because attackers now really are watching these new patches, the new vulnerabilities, and they try to abuse them as soon as possible. So if you do patching on some strictly defined times, like every quarter or half a year, that might not be enough. Identification and authentication failures, another important thing. Yes, so it is important for you, if you are creating or operating an application, that you know who is your user. If you cannot make sure that you verified the identity of your user, then you don't know with whom you are communicating, to whom you are providing your data. To this category also belongs possibility to brute force credentials by using some list of frequently used passwords or well-known passwords, maybe default passwords. Then there is a weak password recovery process, which is also an example of this. Sometimes flaws may happen also in multi-factor authentication. It might be possible that an application allows bypassing the second factor. Or another example is that a session is managed on the client side only. It is important that session is managed on the server side, because everything that's on the client side can be changed, manipulated, and you cannot trust it. In this case, it's recommended to use multi-factor authentication if possible, yes, and also it's a good idea to get some list of well-known passwords, maybe some passwords which were published after some security breach, and to check whether those passwords are used in your system, or actually, if a user is setting a new password, you should check whether it's present in some of those lists. Number 8, software and data integrity failures. This is a good example of this is the SolarWinds attack, which happened last year. The attackers were able to get into the CI/CD pipeline and patch the software by adding some malicious functionality into it. So it is very important to protect also the whole process of building your applications. Another example is the update process. There are applications which can automatically update themselves, which is a nice feature, but they are not always validating the update signature, for example, and then it might happen that you just download some update, but it does something different as you expect. To this category belongs also insecure deserialization, which previously had its own category. Now it's included here. The last example is SRI directives. So if you are developing web applications and you are using some JavaScript from third-party providers or from some content delivery networks, you should keep a hash of those third-party JavaScript, external JavaScripts, and validate whether you are pulling this right JavaScript file into your application when a user is using it. Number 9, security logging and monitoring failures. Yes, so we know it probably not. It is important to log interesting operations from or transactions from the security perspective. If you cannot, if you don't log properly, then you cannot prove that you are attacked. You cannot find out what happened, maybe what the attacker actually did. And if you are doing penetration tests, then it's a good idea to ask at the end from the customer, have you seen any activity? If you haven't seen any activity during a penetration test, then okay, theoretically, it's possible that the pen tester was just too lazy. But then if you get some report with findings and all the details, and you don't see anything in your logs, then you might have a big issue. And the alerting should be done in real time, so you should be able to raise alerts as soon as possible so that you can take action. Number 10, set aside request forgery. This is a new one. It has a low incidence rate. It was found only 9,000 times in 2.7% of applications, but typically, if this kind of issue happens, it has a big impact. because how this works. If you have a SSRF, then your application is pulling or getting some information from another servers, from another URLs. And if you don't control this properly, then it might happen that some attacker will instruct your application to download something that you really don't want to download. Maybe a malware. It doesn't need to download data. If you have an SSRF, then an attacker might, for example, abuse your application to do further exploring within your infrastructure. And since this attacker is already on one of your hosts, there might be some trust established between inside your internal network, and this then it might be easier to proceed. There is also this so-called A11 Next Steps. These are things which did not make it into the top 10, but if you already managed to implement some controls against all those top 10, it's a good idea to also have a look on these issues. Those are code quality issues, denial of service, memory management errors. So for example, code quality issues, one example is that you have some race condition in your code, you have some variable shared between threads, and it might happen that an attacker will be able to read or change data which he's not supposed to change. Denial of service. This does not have to be always a big attack of many terabytes in a second. It might be also some functionality which is consuming too much resources, and then it might happen that an attacker will call this functionality several times within a short time and just exhaust your resources. And the attacker is not going to need any botnets or something like this. Memory management errors, this can be, for example, buffer overflows in some programming languages or platforms. But not only buffer overflows, it might be, for example, inefficient management of memory, like when your application isn't cleaning up memory after some operations, then it might happen that after some time of operation, your memory is just full and the application cannot work and it's unavailable. And if an attacker finds out, then he can abuse this. If you would like to know something more about OWASP Top 10 2021, I recommend you to have a look on these pages. They are very nicely built, even mobile friendly. That's a new feature, and so you can read it everywhere, and all the information, or most of the relevant information, is also available on GitHub. Then I also recommend for you, if you are interested, to watch these two talks on YouTube. The first one from Andrew van der Stok about OWASP Top 10 2021, and the second one from Brian Glass, where he really describes the methodology, how the data analysis was done in this case, and how this worked. So now, enough theory. I will now use OWASP, the OWASP Choose Shop application to show you some examples what could happen if your application is vulnerable. So now you should see my juice shop, but there is a little bit of issue with resolution, so let me fix it. And yes, this application is called OWASP Choose Shop. You can get it on GitHub, and you can use it to practice some hacking or just to have a better understanding how those vulnerabilities work. So here I can show you, for example, injection. Like one of the injection examples is SQL injection. This login form is vulnerable, so we will abuse it. Let's normally I would use my email address here, but maybe I can log in as an administrator. But I need to first find out if this form is vulnerable. So let's open developer tools and let's put something here with this apostrophe. And now some password. Let's log in, and we see that there was an error 500. And let's see what happened. Oh, there was an issue like SQLite error, and there is some. So this might be some issue with the SQL expression. Now we could maybe abuse it, and let's say I already know that the email address of the administrator is admin at is this one, and I put an apostrophe here, which means that the string ends here, and I also end the SQL expression, and let's see what happens. Oh, I'm logged in. And yes, I'm an administrator. Nice. So what else I can do? Yeah. Let's click here and see what functionality we have here. So this was an example of injection. So if we look into this, there is some customer feedback, some complaints, something about us. I can manage my account. Okay. Okay, this is not so interesting for me. Let's say I'm looking now for the number one in the OWASP top 10, and it's access control failure. Looks like this admin is just some less important admin and does not really have access to the site administration. But maybe I could access the site administration by doing some stuff. So let's see. Maybe I could. Let's see if I see now this URL. There's /search. Okay, so this is the search page. Okay, now maybe let's go into the source code of the application of the front end and try to try to find out something more about it. So so now I'm sorry, I don't see what I want to see, but by analyzing the source code, if I would go further, I would find that there's not only this search section and many more sections, but there's also this administration section. So let's click on it. Let's open it. And yes, I just came to the administration section, which actually allows me to see all the users and manage them. And now I will show, this was one example. I will also show you some server-side request for gerry, which is, in my opinion, one of the most interesting issues in OWASP Top 10. And now let me log in as a normal user. I created this account for me, log in. And we have this account, and we observed that in this account, there's this feature which allows you to include some profile picture. It's expected that you include something from gravatar.com, but maybe you could include something else. For example, this nice cat. So let's copy the image link and just put it here. Yes, now link the image. And we need to refresh the page. And yes, so we now included something from a completely different domain than it's expected. And it's not a very bad thing. I don't do very bad things because I'm an ethical hacker, of course, but you can imagine what that this feature might be used for much worse things, like, for example, downloading malware. And if there is, for example, a code execution, then you can later execute this malware inside your victim's infrastructure, which is very bad. You can send you can send requests by abusing this server. So you could use it as a starting point to attack the internal infrastructure of your target. You can abuse your target to conduct attacks against web applications within completely different organizations. There are many bad things that could happen. And since we don't have so much time left, unfortunately, I will stop with demos here, but I really recommend you to have a look on this Juice Shop application if you want to better understand those issues mentioned in OWASP Top 10. There's really a lot of possibilities what you can do. So let me go back to my presentation. The last thing would be questions. Are there any questions?
So Peter, thank you very much for your insights and the refresher on OWASP's best known project, the OWASP Top 10. I think the audience appreciated your talk, and I already have a few questions from the community. So big thanks to everybody out there. Big thanks to the community for being with us and also for your questions. All those that you already sent in, and you may continue sending in additional questions for now. So then let's dive in. Ready for questions, Peter?
Yes.
Then let's start with one person asked himself, well, when I take a look at the content security policy that was mentioned in one slide, and this is considered a risk according to A5, then how is it possible that only 4.5% of applications in the data set actually are vulnerable to it? Is it really the case that more than 95% actually really use CSP headers as they should be used? What's your experience with that?
Let's go back to the slide where I was talking about it. Maybe it will need a bit more clarification. So this security misconfiguration was found in 4.5% of applications, but these are all kinds of security misconfigurations, not only missing content security policy. So we don't really know how many from this information which I currently have. I don't really know how many applications have real issues with the missing content security policy. Maybe you will be able to find it later. If the whole dataset is available, then you can. It is possible. It will be probably possible to do some analysis on this dataset to find out how many applications have issues with this. Not sure if I answered this question. Maybe just briefly about content security policy. So content security policy is a mechanism which should help you to protect your application against cross-site scripting attacks. It might be complicated to set up with modern JavaScript frameworks, because if you configure content security policy too tightly, then you may just lose functionality which is vital for you. But certainly it is possible to configure it. There are tools available. For example, you can Google for Google CSP evaluator, which will help you to if you're using content security policy, this tool will tell you how good or maybe how bad it is. Yes, that's what I can say now. Maybe this could be for longer discussion.
But do you really think that 95% of the applications have a CSP header, according to your experience?
No, for sure not. I'm also pretty sure that this statistics is not trying to tell it. So this 4.5%, it's not telling actually anything about content security policy. It's I really don't know how many applications have content security policy enabled.
Okay, fair enough. Let us stay a bit in the area of data and how to interpret it. There was some guy who actually asked, well, on slide 15, you put logs only stored locally or something like that on the slide. And he asked to himself how to treat that, because, well, usually we're actually putting our logs into a CM or whatever system to make it easier to analyze and generate alerts. What were your thoughts when you wrote that?
So yes, this approach with a CM, which should be typically collecting all the logs centrally, is something that that is recommended. The issue which I wanted to express on this slide is that if you do not use, because not all companies are using CM and similar solutions, there are companies which just companies who are operating applications who are storing logs really on the server where the application is running, and this is an issue. This is an issue which I wanted to point out, because if you consider that your application is under attack and the attacker will be able to gain access to the server, not only to the application, then you cannot trust your logs anymore, because the attacker has access to the server, to the data, and may also change the logs. Therefore, it is recommended to collect logs also centrally, or have those logs on multiple places. If your server is compromised, then at least you will be able to investigate logs which you can trust.
Okay, understood. Thanks a lot for the clarification. Then we have Emmanuel, who is asking whether you could please again show us how the cross-site scripting, cross-site request forgery topic actually blends into the new top 10.
Yes, cross-site request forgery is something that in modern, from my experience, in modern frameworks, cross-site request forgery is actually a security misconfiguration. Not sure what kind of applications you are developing, what kind of frameworks you are using. But for example, if you are using Java, you might be using Spring, or maybe if you are using Python, you might be using Django for developing applications. In such frameworks and many others, cross-site anti-CSRF tokens, which are actually the mechanism to protect against CSRF, those can be added just by doing configuration, and that's all. And also, yes, cross-site request forgery does not seem to be so frequent anymore. Previously, it had its own category, but now it seems to be really only one of the many possible security misconfigurations.
Emmanuel clarified right now for IoT in C, for instance. Any thoughts on that?
Unfortunately, I don't have so much experience with IoT and the C language. Not sure if this is a typical platform for web applications, and the CSRF. According to my experience, CSRF is an issue related to web applications. So. Unfortunately, I cannot give you now a good answer. Maybe you could send me an email. We can discuss it later.
Fair enough. Thanks a lot. So now let's leave a bit the more technical part of the OWASP Top 10 task for the next few questions. I have one that asks, how would you recommend to get product owners or similar roles to care a bit more about OWASP Top 10 and security in general? So get budget from there to fix actually the stuff and make that right.
That's not an easy question for me, because I did not have much chance to work with product owners and to trying to convince them to do something in security. But generally, I think a good way to go is to work with developers, not really with the product owners, unless you have a real security issue. I think if you have a real security issues which can be exploited, and you can really show that the issue is there and it can be exploited in the production, then I strongly believe that most of the product owners will acknowledge it, that such issues should be resolved with priority. If you don't have currently big issues, but you want to just to improve the overall security of your application, I would probably not go to the product owner, but I would try to work with developers and try to find ways how to develop the application and implement features with focus on security. So you can automate many things. I mentioned during my talk that many injection issues could be tested with automated tools. Some things like cryptographic failures, XML external entities, vulnerable or outdated components. You will detect these with your static source code analysis. You can do software composition analysis. There are even free tools. There's also a tool from OWASP. I cannot recall now the name, but there is a tool which immediately tells you whether there are some vulnerable dependencies in your Maven repository in Java projects. So I think I would try to introduce as much automation as possible, and then yes, work with developers to integrate this into their pipeline. And maybe sometimes if you have an opportunity to give a presentation, then give a presentation how issues can be exploited, and it is possible that your product owner will be interested in it.
What maybe for my 2 cents on that would be to one approach is make them kind of responsible for it. So create a risk list for them, walk them through the risk list, assess the risks together, and make sure this risk list is actually then distributed within the whole company, so that more than just your product owner is aware, but your whole organization. Then soon you have the chance that it becomes a kind of target for the organization to reduce risk also. So make it visible what the problem is when you don't actually assess the risks correctly and mitigate them. That would be maybe a first step in that direction, to make product owners aware of what their problems actually are in this area, and also to make them aware and willing to spend time and money for non-functional issues. So then we have a few other questions. For example, one that reached me is, well, some of this new top 10 topics are quite hard to assess during a traditional pen test. So has this actually impact on your job as a pen tester? Do you do a pen test now differently than you did it before?
From my experience, not. I don't think much changed. Of course, we are always looking for new risks which are present. So some time ago, we added some. We built up some know-how regarding SSRF at our company, but fundamentally not much changed. We typically try to watch what happens, what issues are introduced in applications, what vulnerabilities are discovered, and based on this input, we try to build up our testing methodology. This OWASP top 10 maybe this could be also interesting to mention that this OWASP top 10, it's not intended to be as a standard, because yes, as you mentioned, it's very general, and you cannot just implement some pen testing strategy or application security program based on these general 10 points. If you want to do something like this, I think there's another OWASP project, correct me if I'm wrong, it should be the application security verification standard. So maybe this could be interesting for you if you want to build up some standard at your company to assess application security.
Mm-hmm. Thanks a lot. Then another one that's a bit the side topic is, would you say that the top 10, the new top 10 actually match what you see in your daily life when doing a penetration test? So do you think they got it right?
Well, it's not exactly the same as my experience, but many things I actually agree with most of the things. For example, broken access I fully agree with the reasoning behind the broken access control, that it's a real issue. Interesting is that this issue, it is very hard to test this automatically. You cannot just create some product which will generally be able to test any kind of applications for access control, because different applications have different user roles, different permission system. Therefore, I think broken access control is one of the most important topics, for example, for me as a pen tester. I see cryptographic failures as defined here also very frequently. Injection, I fully agree that it's still a thing, but maybe not so often. And I would maybe put a cross-site request for gerry to this list if I should build it up only on my personal experience, but it doesn't really matter.
Thanks a lot. We have another question from Crazen, actually. He's interested in penetration testing tools you use. You already mentioned a few tools like the OWASP dependency check, for example, to figure out what third-port vulnerabilities you have. What other penetration testing tools do you actually use, or would you recommend?
Well, for a start, I would recommend for sure the OWASP ZAP proxy, which is also an OWASP flagship project. It's a very useful tool for testing web applications. You can typically you can set up it as a proxy behind your web browser, and you can watch all the communication between your browser and the application. You can manipulate requests, do automated tests, for example, for injection issues. So if you're a beginner and you don't want to pay much for the tools, for sure I would try this Zap proxy. And yes, the Juice Shop is also a good source for learning. And then yes, depends on what you want to test. If you go to the OWASP web pages, there is really a lot of projects managed by this organization. There are also, for example, scanning tools to scan your source code, to scan your third-party libraries. You will find many things there. And then there are, of course, products which you have to buy. Yes, that. But for the beginning, I would start on the OWASP page.
Mm-hmm. Mm-hmm. This brings us maybe directly to Indigolo's question. Part of it you already answered, but he's asking you, how do you personally stay up to date about new techniques and new vulnerabilities that are out there in the wild? So do you talk with them, with other members of your team, for example, or do you have any tips for public available resources to stay up to date?
Yes, I think the main source for me is my team, because we have we are like a mid-sized company, Compass, and we have multiple pen testers here who work on many different projects, and we are sometimes just talking about issues which we found, especially if those issues are somehow interesting. So we for example do a coffee break and talk about this as one of the topics. If there are some very interesting topics, then we do presentations internally for the company so that everybody knows about it. So yes, working at a pen tester company, it's quite easy for me to stay up to date. But otherwise, you can watch. I cannot tell from now immediately some sources. Maybe we could talk about this later if you send me an email, but typically one of the possibilities is following some people on Twitter who publish interesting information. There are some people or organizations that are active on LinkedIn who are also publishing information. There are sites like news sites which are really, or blogs which are specializing on security related news. And there are also many other projects, or maybe not so many, but there are also other projects similar to this Juice Shop where you can just practice hacking, pen testing, and they typically also try to be up to date all the time. So if you are watching these projects or sites, then you probably you will know if there each time when there's something new and interesting.
Thanks a lot. Oh, last minute question. We still have, well, last question then from Indigolo. Looks like he's interested really in what you have to say, and he considers maybe also a career in this area. So what are the career possibilities for a pen tester? So is it a job for a lifetime? Is it repeating always again and again? Or is it inspiring? new methods always, new learning? What are your thoughts on that?
So for me, I like my pentester job because there's always something new to learn. So there will be probably never a time when I will say, okay, I already know everything. I have nothing more to learn. I also like that I have an opportunity to find some issues and report them before they are abused by somebody, and I'm actually making at least the yes, actually not only the digital part of the world safer. That's what what I think about my job. It can be how the career can evolve. It might be different. Some people go to software development. Sometimes I think currently it's many companies are looking for people who have experience both with the software development and security. Many people when they quit the pen tester job, they go to organize pen tests actually. So they work for some company and they are responsible for finding out which applications at the company or which infrastructure needs a pen test, and then they get the pen test and evaluate the results. I think there are many possible paths in not only in security but also in software development.
So definitely a path to go if you like it. Thanks a lot. Peter, thanks again for sharing your insight and for giving this talk with us. It was very much appreciated. And thanks to the community for being here with us. I want you to make aware that the slides will be shared by Peter, so you will have access to them and you can look them up where you actually looked at the meetup, or the recording also will be shared on YouTube too, so you can also rewatch if you like to. Just give us a day or two to prepare everything. So with that, I wish you all a very nice evening and have a good time. Bye and see you soon again, hopefully.